Okay, so let's go ahead and take a look at your next lesson. So your next lesson is all about antiderivatives. So let's take a look at the fundamental theorem of calculus part 2. It's pretty obvious. When you take the antiderivative, you take the top boundary minus when you plug in the bottom boundary. So I'm going to first take the antiderivative. So 4 1/4 x to the 4th plus 1/2 x squared and minus x. And I'm evaluating it from 0 to 2. So x to the 4th plus 1/2 x squared minus x, going from 0 to 2. That means 2 to the 4th plus 1/2 2 squared minus 2, and then minus a bunch of zeros. 0 to the 4th plus 1/2 times 0 squared minus 0. So when I do this, 2 to the 4th, and then my plus 1/2 2 squared, and then minus 2, I get 16. Antiderivative of sine is cosine, negative cosine, going in parentheses from negative pi to pi. So then this is negative cosine of pi minus negative cosine of negative pi, and then cosine of pi is -1, and then this is plus cosine of negative pi is -1, so I get 0. Because that's 1 minus 1. Okay. Next one. If my integral is equal to 30, then find out what k is equal to. So I'll take my antiderivative first. 4 1/2 x squared plus x. Evaluating this from -2 to k, and this is supposed to equal 30. So then I get 2x squared plus x. Going from -2 to k is equal to 30. So 2k squared plus k minus 2 times -2 squared minus 2. And this is supposed to equal 30. So I get 2k squared plus k minus 6 is equal to 30. So 2k squared plus k minus 36 is equal to 0. So then I have to factor. So I have 2k and k, and then a plus 9 and a minus 4 would work. So then my k would be equal to -9/2 and 4, but I said that k had to be bigger than 0, so k is 4. Okay. This requires a little bit of u substitution here. So u is equal to 3x, so du is equal to 3 dx, so dx is equal to du over 3. And then normally when we do u substitution, we also have to change our boundaries. So I need to find u of 2, and I need to find u of 5. So u of 2 is 3 times 2, comes from my u is equal to 3x here, so that's 6. And then 3 times 5, which is 15. So this is the antiderivative from 6 to 15, g of u du over 3. So I know that my derivative is equal to g, which means that my antiderivative of g is equal to my original f equation. So I get 1/3 f of u, and then evaluated from 6 to 15. So then when you do u substitution, you don't resubstitute your u back in. So then this is 1/3 f of 15 minus 1/3 f of 6. Using a graphing calculator, evaluate this function. Okay, So let's take a look at our graphing calculator. So I'm going to plug in my equation into y equals. So y equals, parentheses, 4 minus x squared, and then to the 1/2 power. And then I'm going to use fnet. So I'm going to go second quit. Is there a problem with my? I think we're okay. Okay, second quit. Math. Fnet is 9. So I'm going from -2. So make sure you use the negative sign and not the subtraction sign. And then I don't want to type in my equation, so I'm going to go vars, scroll to the right, enter on function, enter for y1, and then plug in dx, which is the use your xt theta n button, and then you'll hit enter. And you get 6.283, which is actually 2 pi. But you should round to 3 decimal places, no bigger than that. So we'll say that it's 6.283. Okay? Okay, so example 5 is 6.283, I feel like. I guess you could just put 2 pi because I said it was 2 pi. But you do want to round to 3 decimal places. All right. Fundamental theorem of calculus part 1 is taking the derivative of the antiderivative. Example 6 is kind of in the wrong spot. I'm going to start taking the derivative of the antiderivative with example 7. So with example 6, we're going to use u substitution. So u is equal to 2t. So du is equal to 2 dt. So dt is equal to du over 2. And then I need to find u of pi and u of pi over 4, which is 2 pi and pi over 2. So then I take my integral, pi over 2, 2 pi, cosine of u du over 2, antiderivative of cosine is sine of u, and we're multiplying by half, and we're evaluating from pi over 2 to 2 pi. So this is 1/2 sine of 2 pi minus 1/2 sine of pi over 2. Sine of 2 pi is 0, so then I get 0 minus 1/2 sine of pi over 2 is 1, so I get negative 1/2. Okay, so now let's take some derivatives of some antiderivatives. We take the derivative of the antiderivative. Remember, you take your top boundary, provided it's the variable. You ignore the number in the bottom. You take it and you substitute it in for your variable t. And then you multiply by the derivative of the variable. So h prime of x is root x plus 1 times the derivative of x, which is 1. So h prime of x is equal to root x plus 1. I want to find h prime of 8, so h prime of 8 is equal to root 8 plus 1. So then you get the square root of 9, which is equal to 3. Okay? So we'll do it again. Find your dy dx. So I'm going to take my 2x, I'm going to plug it in for t. So dy dx is equal to 1 over 2x, the quantity cubed, times the derivative of 2x, which is just 2. So I get 2 over 8x cubed, which is 2 over 4x cubed. If my variable is in the bottom and the number's in the top, then I need to flip them and make it negative. So I have negative 1 and x squared on the top, and then sine of t dt. So then dy dx is equal to negative sine of x squared times the derivative of x squared, which is 2x. So dy dx is equal to negative 2x sine of x squared. 10. When you have variables in the top and in the bottom, then you need to pick your favorite number and split the integral. So I'll pick my favorite number as 0. So I'm going to go from 0 to x squared root e to the t plus 1 dt. And then I'm going to go from x to 0 root e to the t plus 1 dt. Because my x is in the bottom, I have to flip in to make it negative. So 0 to x squared root e to the t plus 1 dt minus 0 to x root e to the t plus 1 dt. So then I get root e to the x squared plus 1 times the derivative of x squared, which is 2x, minus root e to the x plus 1 times the derivative of x, which is 1. So I get 2x root e to the x squared plus 1 minus root e to the x plus 1. Okay. Next one is just a basic antiderivative. So I'm going to change my root x to be x to the 1/2 power. And then I'm going to divide both terms by it. So I get 1 to 4 x cubed over x to the 1/2 minus 8 over x to the 1/2, and then dx. And then I subtract my exponents. So 3 minus 1/2 is 2.5, which is 5/2. So this is antiderivative from 1 to 4, x to the 5/2 minus 8x to the negative 1/2 and dx. So then I get antiderivative of 5/2, so 2/7 x to the 7/2 minus 8 times 2x to the 1/2. And I'm evaluating this from 1 to 4. So I'll clean it up a little bit. 2 over 7 x to the 7/2 minus 16x to the 1/2, and I'm evaluating from 1 to 4. So then I plug in 2 over 7, 4 to the 7/2 minus 16, 4 to the 1/2, and then minus 2 over 7, 1 to the 7/2 minus 16, 1 to the 1/2. So I get 2/7. This is the square root of 4 and to the 7th power minus 16 times the square root of 4, and then minus 2 over 7 and plus 16. So then I get 2/7, and then I get 2 to the 7th power minus 16 times 2 minus 2 over 7 plus 16. So then I get 256 over 7, and then minus my 32 is 224 over 7 minus 2 over 7, and then my 16 is 112 over 7, and so then when you simplify, you get 142 over 7. Okay, so example 12. Let u be equal to x squared minus 1, so du is equal to 2x dx, so dx is du over 2x. So then u of 2 is equal to 2 squared minus 1, so that's 4 minus 1, which is 3. U of 0 is equal to 0 squared minus 1, which is negative 1. So then I have my antiderivative, negative 1 to 3 x u to the 7th du over 2x. So my x's go away. I'm left with 1/2 u to the 7th from -1 to 3 in du. So 1/2, 1/8 u to the 8th, -1 to 3. So I get 1/16 3 to the 8th minus 1/16 -1 to the 8th. And so I get 6,561 over 16 minus 1 over 16. So then 6560 over 16, which actually divides it evenly, and it's 410. Example 13. -8 to -1, y to the 1/3 plus y to the -1/3 dy. So I get 3/4 y to the 4/3 plus 3/2 y to the 2/3 -8 to -1. So I get 3/4 -1 to the 4/3 plus 3/2 -1 to the 2/3, and then minus 3/4 -8 to the 4/3 plus 3/2 -8 to the 2/3. So now I simplify, and I get 3/4 plus 3/2 minus 3/4 times 16 plus 3/2 times 4. So 3/4 plus 3/2 minus 48 over 4 minus 12 over 2. So put everybody in common denominator 4. So 3/4 plus 6/4 minus 48 over 4 minus 24 over 4. So I get -63 over 4. So the next couple of ones are a little bit tricky because they involve absolute value. Okay, so remember with absolute value, I can take my absolute value equation and I can first take my 3x minus 6 and set it equal to 0. When I do that, I get 2. I can take my absolute value equation and I can write it as a piecewise function, and we did this back in advanced math. So I first take what's inside my absolute value and I set it equal to 0 and I get 2. So then I can write my absolute value as 3x minus 6 if x is bigger than 2 and negative of 3x minus 6 if x is less than 2. Okay, and I can put, remember, I can put my equals bar kind of wherever I want to. Okay, so I can put it with the top one or I can put it with the bottom one. I just can't put it with both. So remember that I can separate out, and it's positive when it's bigger than the value of 2, and it will always be negative when it's smaller than that. Because remember, your absolute value, in order to drop absolute value bars, you have to guarantee that whatever you plug in for x will always be positive. And bigger than 2 would make my top equation always positive, and less than 2 would make my bottom equation always positive. So that's how we split up our absolute value. That's how you're actually going to evaluate this integral. I'm going to go from 1 to 2, and that is smaller than 2, of negative of 3x minus 6 dx, and add it to, when I go from 2 to 4, or my positive 3x plus 6 dx. So then when I take this antiderivative, I'm going to get negative of 3 halves x squared minus 6x And I'm going from 1 to 2 plus 3/2 x squared minus 6x, going from 2 to 4. And then I just evaluate it. So I have negative 3/2 2 squared plus 6 times 2 minus negative 3/2 times 1 squared, and then plus 6 times 1, and that's my first bracket, plus 3/2 times 4 squared minus 6 times 4, and then minus 3/2 times 2 squared minus 6 times 2, and that's my second bracket. So then I get negative 3/2 times 4 plus 12, and then I get plus 3/2 minus 6 plus 3/2 times 16 minus 24 minus 3/2 times 4 and plus 12. So simplify even more. So negative 6 plus 12 plus 3/2 minus 6 plus 24 minus 24 minus 6 and plus 12. And when you simplify this, you get 15/2. Okay? So now I'm going to do the next one. I'm going to just change colors because we've used a lot of this purple color. So first step, set my x squared minus 4 equal to 0 and solve. So I get plus or minus 2. So then my absolute value of x squared minus 4 separates out to x squared minus 4 if x is bigger than or equal to 2, or x is less than or equal to negative 2, and then it's negative of x squared minus 4 if x is between negative 2 and positive 2. Okay, and you would test this out. So this is kind of back to like the advanced math thing. You know, when I drop the absolute value bar, it has to be bigger than 2 or less than negative 2 in order for x squared minus 4 to always be positive. Okay, so now I'm going to set up my integral. I'm going from 0 to 4 of the absolute value of x squared minus 4 dx. This is the same thing as going from 0 to 2 x squared minus 4 dx plus going from 2 to 4. Oh, this guy should be negative. I'm sorry. Of the positive guy, x squared minus 4 dx. So then I take my antiderivative. Got a little bit of problems here. So negative of 1/3 x cubed minus 4x, going from 0 to 2 plus 1/3 x cubed minus 4x, going from 2 to 4. So then I get negative 1/3 2 cubed plus 4 times 2 minus 1/3 times 0 cubed plus 4 times 0. And then plus 1/3 times 4 cubed minus 4 times 4 minus 1/3 times 2 cubed minus 4 times 2. So then I get negative 8/3 plus 8 plus 64 over 3 minus 16 minus 8/3 and then plus 8. So I get, after I simplify, 16. Okay, so those are kind of weird You will rarely see those types of problems, but I wanted to show you guys just in case you happen to see them on the actual AP test. Okay, doing some more integrals. Antiderivative of x is 1/2 x squared. Antiderivative of sine is negative cosine, and I'm going from 0 to pi. So then I have 1/2 pi squared minus cosine of pi minus 1/2 times 0 squared plus cosine of 0. So 1/2 pi squared minus a -1 minus 0 plus 1. So I get pi squared over 2 plus 2. 17. Cosecant squared of 3t, so u is equal to 3t, so du is equal to 3 dt. So dt is equal to du over 3, so u of pi over 2 is 3 times pi over 2, so 3 pi over 2. And then u of pi over 4 is 3 times pi over 4, so 3 pi over 4. So then I have the antiderivative from 3 pi over 4 to 3 pi over 2, and I'm doing cosecant squared of u du over 3, so I get -1/3 cotangent of u, evaluated from 3 pi over 4 to 3 pi over 2, so I get -1/3 cotangent, that's weird, cotangent 3 pi over 2, and then plus 1/3 cotangent of 3 pi over 4, and the cotangent of 3 pi over 2 is 0, and the cotangent of 3 pi over 4 is -1, so I get -1/3. Okay. Next one, we're going to do another u substitution, so we're going to let u be equal to the lambda t, so du is equal to 1 over t dt, so then dt is equal to t du, u of e is equal to the ln of e, which is 1, u of 1 is the ln of 1, which is 0, so I get antiderivative from 0 to 1 of u over t and then t du, so then the t's cancel out. I'm left with 0 to 1 u du, which is 1/2 u squared, evaluated from 0 to 1, so 1/2 1 squared minus 1/2 0 squared, so I get 1/2. And then the last one, u is equal to x squared plus 1, so du is equal to 2x dx, so dx is du over 2x, yes. U of 2 is equal to 2 squared plus 1, which is 5. U of -1 is -1 squared plus 1, which is 2. So I have the antiderivative from 2 to 5, x e to the u du over 2x, and the x's cancel out. So I'm left with 2 to 5, 1/2 e to the u du, which is 1/2 e to the u, evaluated from 2 to 5, so 1/2 e to the 5th minus 1/2 e squared. And that is it for this lesson.